When talking about performance, we cannot forget about the actual hardware configuration that will support our database and application deployments. A full disclosure of how to tune and size your hardware needs for a given deployment are out of scope for this course. We have other specific courses on this subject that we recommend you guys to take. But let's just do a quick pass on the hardware and configuration of our system and why it becomes an essential consideration for the overall performance of your deployment. MongoDB is a high-performance database, but to operate correctly while supporting your applications requires adequate hardware provisioning. Let's review which hardware resources and configurations we have available and how MongoDB uses those computational resources. A computer or server can be represented in its essence by the von Neumann architecture, where we are going to have a CPU for processing and calculations, memory for execution, disk and I/O, although you may consider disk as another type of I/O, for persistency and communications between servers or even within our host processes. These are the main resources that MongoDB relies to operate adequately. In a MongoDB deployment, as in many other modern databases, memory is a quintessential resource. Over the past few years, the availability of RAM and the fall of its production costs contributed for the development of databases architectures that privilege the usage of this fast and performant resource. The fact that RAM, or memory, is 25 times faster than common SSDs also makes this transition of disk-oriented into RAM-oriented a nice, strong, appealing factor for databases to be designed around usage of memory. As a result of this, MongoDB has storage engines that are either very dependent on RAM or even completely in memory execution modes for its data management operations. A significant number of operations rely heavily in RAM, like the aggregation pipeline operations, the index traversing. Writes are first performed in RAM allocated pages. The query engine requires RAM to retrieve the query results. And finally, connections are handled in memory, roughly 1 megabyte per established connection, and therefore they require memory space. It is safe to say that the more RAM you have available, the more performant your deployment of MongoDB will tend to be. CPU is used by all applications for computational processing. Databases are just another category of applications. MongoDB is no different, but the utilization of this resource is generally more attached with two main factors: storage engines that we are using and the concurrency level that your MongoDB instance will be subjected to. By default, MongoDB will try to use all available CPU cores to respond to incoming requests. Our non-locking concurrency control mechanism, using WireTiger storage engine, rely heavily in CPU to process these requests. This means that if we have non-blocking operations, like writing different documents concurrently or responding to incoming query requests, like reads, MongoDB will perform better the more CPU resources we have available. Also, there are certain operations like page compression, data calculation operations, aggregation framework operations, and MapReduce, amongst others, that will require the availability of CPU cycles.